Hello, this is Lab 5 Magnetic Braking with Faraday by Raghav Grover. So, just a short introduction. Faraday's law relates time varying magnetic field to a Curry electric field whose path integral around a closed path is not zero but provides an EMF that can drive current. This current in turn produces a magnetic field which exerts a force on the source of the external magnetic field, which in this case was the falling bar magnet. And the induced current is driven in of an aluminium foil in this case. And this interaction between the falling magnet and the tube of aluminium foil produced an interesting result, which I will talk about in the course of this lab. Now, essentially the concepts covered in this lab are Faraday's law, Biot-Savart's law, and Newton's second and third laws. Let me explain the procedure and the experimental values. So the procedure was simple. I recorded the average time of dropping of a magnet through the tube with aluminium foil wrapped around it. And I recorded this 5 times and compared the code prediction with this data that I took and saw how much it matches. So here's the time for every single one of these trials. And here's also the average time. Now, let me just break down the stuff that I edited in the code. I filled in the dimensions according to my measurements. I used the magnetic dipole that I measured in lab 3. And a function was created that would calculate the field of the bar magnet. And a function was also created to calculate the magnetic flux. And gravitational force and magnetic force, that the calculations were essentially added in the grand scheme of things. And then the calculation of the current of a ring at that particular location was added, and then the B field at each ring was computed using this current value. And then the magnetic force was updated accounting for this B field. At the end of it, the magnetic force and the gravitational force was summed up to form the net force, which was used to edit the bar magnet's velocity and position. The results that I got from this code was that my computational model predicted a time of 1.31 seconds and my experimental time was 1.43 seconds, which is a rather close value, and the error can be attributed to various factors in the experimental process. And I even recorded the time when free fall, which came out to be around 0.32 seconds. Thank you.